Hi everyone, this video is on the quadratic formula. Here is the quadratic formula. Given the quadratic equation, ax squared plus bx plus c equals 0, x equals, in the numerator, negative b plus and minus the square root of b squared minus 4ac all over 2a. And we just have one condition that a cannot equal 0. One thing it doesn't say there is that a should be positive. It's not a requirement, but it definitely makes it easier if you have a positive value. It avoids having a negative in the denominator. So if you do have your a as a negative number, you might as well multiply the whole equation by -1 to get rid of the negative. Okay, so just keep that in mind. Where does this formula come from? It comes from the method of completing the square. I won't show the proof here, but it's definitely a good idea to look at the proof of the quadratic formula. Where does this come from? Okay. Before we get started, let's practice simplifying some rational expressions. We've done this before. It's kind of like a cheating way of reducing. Alright, so don't tell anybody. This is just between us. Don't tell any other math teachers because it's not really proper. It's just kind of a shortcut. Okay, let's look at the first one. 6 plus 8x over 4. What we want to do is find a number that goes into all three numbers that we have there, 6, 8, and 4. What number goes into 6, 8, and 4? That would be 2. So we're going to divide all the terms by 2. So 2 goes into 6 3 times, 2 goes into 8 4 times, and 2 goes into 4 twice. Now just rewrite it. We have 3 plus 4x all over 2. The proper way is to factor out a 2 in the numerator and then reduce it, but this is kind of our shortcut. Okay, let's do the same thing with b. What number goes into all the numbers except for the square root 3? So we're not worried about the square root of 3. It's kind of like the x in the problem above it. What number goes into 6, 12, and 18? Right, 6. So we're going to divide all the terms by 6. 6 goes into 12 twice, 6 goes into 18 3 times, and 6 goes into 6 once. And then we can rewrite it. Since it's a 1 in the denominator, we don't have to worry about the denominator. Okay, so if that 18 was a 17, for instance, then we could not reduce the 6 and 12. It has to be all three or nothing at all. Okay, here's our first example. X squared plus 5x minus 3 equals 0. We want to solve this using the quadratic formula. So it's in the proper form. We have a 0 on the right-hand side. Our trinomial is in descending order. The squared, the x, and the constant. I put a note here. The first thing we're going to do is identify what a, b, and c are by comparing to the standard form ax squared plus bx plus c equals 0. Okay, and it is. Then we're going to replace those numbers into the quadratic formula and simplify. And I just wanted to write this, that since you need to memorize the formula, you may be watching this video right now while we're doing education online or remotely because of the coronavirus. But you still should memorize the formula because it's going to come up in every math class that you have from now on. So it's always a good idea to memorize these formulas. Many people, like myself, have to write things down in order to memorize something. I can't just look at something and memorize it. I have to physically write it down. Even when I read, I try to write down things. Otherwise, I don't understand what I read. So anyways, the more times you write something down, it will help you to memorize whatever it is you need to memorize. Okay. So we're going to write down the quadratic formula. And again, uh, you might want to make note cards. Note cards are always a great thing to do, even in math. Sometimes math classes get neglected as far as note cards. You might be writing down note cards for biology or anatomy, history, but a lot of people don't do it for math when you should. So definitely note cards. What is the quadratic formula? Negative b plus and minus the square root of b squared minus 4ac all over 2a. Make sure that your bar goes all the way across. Some people don't write the bar all the way across and they don't have the negative b over in the numerator. It's then wrong if you don't do that. You don't want to get it wrong. Okay, and then a, b, and c. A is number in front of the x squared. There is no number, so it's a 1. B is a 5, and c is negative 3. Now we're going to substitute a, b, and c into the quadratic formula. So x equals negative 5 plus and minus square root. Again, replace the b with 5. That's why it's 5 squared. The 4 is part of the formula. Times a. A is 1, so I put it in parentheses. Times c. I put the negative 3 inside parentheses because it's multiplication. Now our next job is to simplify. I also should have said on the bottom it's 2 times a, 2 times 1. So simplify now. 5 squared is 25. We have 4 times 1 times negative 3. That's negative 12, but there's already a negative in front, so that'll change it to a positive 12. And then in the denominator is 2 times 1, which is 2. So inside the radical, the radicand is 25 plus 12. We could add those two numbers together. We have the square root of 37. 37 is a prime number. It will not simplify. There's no pairs in there. So that's our final answer. Negative 5 plus and minus square root 37 all over 2. This is a condensed way of writing our answer. We could write it negative 5 plus square root 37 all over 2 and negative 5 minus square root 37 all over 2. Okay, this is our next example. 3x squared plus 2x minus 4 equals 0. It's already in the correct form. So let's write down the quadratic formula and then a, b, and c. You haven't memorized yet? That's okay, you still got time. So negative b plus and minus the square root of b squared minus 4ac all over 2a. Again, keep writing it down. It'll help you to memorize it. Write down what a, b, and c are. A is 3, b is 2, c is negative 4. Now we're going to substitute those into the quadratic formula. So wherever we see an a, replace it with 3, b, replace it with 2, c, replace it with negative 4. Okay, so negative 2 plus and minus the square root. 2 squared minus 4 times 3 times negative 4 all over 2 times 3. Now we can simplify. 2 squared on top is 4. On the bottom, 2 times 3, that's a 6. And then 4 times 3 times 4. 4 times 3 is 12. 12 times 4 is 48. The 4 is negative, so it's a negative 48, but there's already a minus in front, so it turns into a positive 48 or plus 48. Okay, so now in the radical, we could add the 4 and 48. That will give us 52. We can simplify the square root of 52. It's 2 times 2 times 13. So a 2 comes out and a 13 stays inside. So now we have negative 2 plus or minus 2 square root 13 all over 6. Here's that shortcut. We can reduce because there's a number that goes into all three numbers, not including the 13 because the 13 is in a radical. So what number goes into 2, 2, and 6? Right, 2. 2 goes into the first 2 once, 2 goes in the second 2 once, and then 2 goes into 6 3 times. So that gives us negative 1 plus and minus 1 square root 13 all over 3. Now the 1 in front of the 13, usually we don't write it. It's not wrong if you do, just not written. So there's our final answer. Negative 1 plus and minus the square root of 13 all over 3. Okay, here's our next example. X times 3x minus 10 equals 25. All kinds of problems here, right? We don't have a 0 on the right-hand side. The left-hand side isn't in standard form. We don't have the ax squared plus the bx plus c. So we're going to have to put it in the right form. We're going to have to get a 0 on the right-hand side and get the left-hand side in order. So first thing we're going to do is to distribute on the left-hand side, and then we're going to get a 0 on the right-hand side. So distribute on the left, distribute the x. So what does that give us? X times 3x, 3x squared, and then x times negative 10 is negative 10x. Okay, so that's 3x squared minus 10x. Now we need to get a 0 on the right-hand side, so subtract 25. When you move the 25 from one side to the other, the sign will change, and then put it at the end because that's the constant. So we have 3x squared minus 10x minus 25 equals 0. Now we can write down our quadratic formula, the a, b, and c. So here's our quadratic formula. A is 3, b is negative 10, and c is negative 25. So we're going to substitute into the formula, and then we're going to simplify it. Okay, so replace the a with 3, the b with negative 10. Be careful with the b because it's a negative 10, but b is already negative. So when you replace b with negative 10, it's going to be negative, negative 10, two negatives, which eventually will turn to a positive. Okay, so here we go. So there's that negative, negative 10 in front of the radical. And then when we replace b with negative 10, I put it in parentheses because we want to make sure that we square the negative also. And replace the a and c as well. So in front, we have negative, negative 10. That turns into positive 10. Inside the radical, negative 10 squared is 100. And then when we multiply 4 times 3 times 25, there's two negatives there, so that'll turn into a plus. 4 times 25 is 100, and then 100 times 3 is 300. So now we have 10 plus and minus inside the radical, 100 plus 300 all over 6. 2 times 3 was 6. We could add the numbers inside the radical. 100 plus 300 is 400. Now we can simplify the square root of 400. The square root of 400 is 20. And here we can keep going. Because 400 was a perfect square root, it gave us an integer. So this gives us two problems to work out. 10 plus 20 over 6, and then 10 minus 20 over 6. Okay, 10 plus 20, that'll give us 30 over 6. And then 30 over 6 reduces to 5. On the bottom, 10 minus 20 is negative 10. So we have negative 10 over 6. We can reduce that by 2. That gives us negative 5/3. So this one gave us two answers, negative 5/3 and 5. There's no radical, which means it actually could have been factored. The original trinomial, 3x squared minus 10x minus 25 equals 0. We could have solved that by factoring. However, the directions were to solve using the quadratic formula. So that's why we did that. Always follow directions, right? Okay, we have one more example. Not a long lesson. All right, our last example. This one is already in the right form, ax squared plus bx plus c equals 0. So we can write down the formula. And our a, b, and c. A is 1, b is negative 2, and c is 19. Okay, so now we'll substitute into the formula. Now we can simplify. So there's that negative 2 in front. That turns into a positive 2. And inside, make sure we have the negative 2 inside parentheses. So negative 2 times another negative 2 is positive 4. And then the 4 times 19 is 76. So we have 2 plus and minus the square root of 4 minus 76 all over 2. Keep simplifying inside the radical. 4 minus 76 is negative 72. We have a negative inside the radical. That means we have a complex number. So we're going to write it in the form of a complex number. Let's see, square root of 72 is 6 square root 2. But we have an I because of the negative. So 6i square root 72. Sorry, 6i square root 2. Now, because it's a complex number, we have to write it in the form of a complex number, a plus and minus bi, or a plus bi. So we're going to write them both over 2. 2 over 2 plus and minus 6i square root 2 all over 2. Then we can reduce that. 2 over 2 is 1, and 2 goes into 6 3 times. Okay, I'll see you here for the next one.